Good evening, everyone. Welcome to this live session. Herein, we will take your doubts, and you can keep on posting your doubts into the chat box. I hope you are enjoying the course, and it will be definitely very enriching and will enhance your learning in this field of hydrogen. So we will have every month, we will have one such live session wherein we will clear your doubts. You can keep posting your questions in the discussion forum as well as for this particular session, which we will have. And now we can begin with we will take up certain questions which have been posted earlier. In the meantime, you please post your questions in the chat box. Until we get further more questions to answer in the chat box, we will pick up certain earlier questions and we'll start answering those.
So one of the questions asked by Sayak Bhattacharjee is in two parts. So what is the scope of green hydrogen in India in terms of R&D, not just limited to academia, but in terms of dedicated industrial R&D opportunities in PSUs as well as private sector MNCs or startups over the next 30-40 years?
Okay, so see the dynamics. Maybe I think everybody would have heard this question. This is about the scope of green hydrogen, and that is not only in academic perspective, but as well as the industrial and PSU's perspective. A lot of work is being done, and you have all heard about the National Green Hydrogen Mission. There are a lot of incentives which are given for green hydrogen production. So it's a sort of transient phase wherein a lot of development each of one of us are going to witness in due course. So if you have seen the different programs which National Green Hydrogen Mission is now supporting in the sense of not only R&D proposals, but pilot scales, developing pilot scales, taking the technologies to higher TRL level, uh, site programs wherein the green hydrogen production, that is the hydrogen being produced in a green manner, as well as the electrolyzer manufacturing is being incentivized. So a lot of this is in Indian perspective, but a lot of work is also being done globally, wherein such similar targets and incentives are there in the different countries, different continents. And a lot of strategies have been announced how they are going to progress. These targets, mission documents, roadmaps have been announced over a period of time in phased manner, wherein the progress will be reviewed in durations, and then the corrective measures, whether the target needs to be enhanced or whether the incentives or the policy should be in place. All these things are going on globally. So we can say that a lot of progress could be seen in today's marketplace. A lot of changes taking place in terms of the government support, the policy support. Different industries are coming up towards adopting hydrogen. We see a very positive future, but actually it is a transition phase, we will say.
On a similar note, there is another question asked in a Q&A session that if green hydrogen can help India in becoming energy self-sufficient and reduce or eliminate dependency on fossil fuel, then what could be the probable reason for this transition being slow? Is it supply demand gap or policy or the combination of both?
See, what we are seeing is in this growth has been what we are witnessing is over a period of few years. Now, any fuel transition, if you see, it is a very big drastic change. Even adoption of EV took certain time, and there was support which which is driving that transition. So it cannot happen in a day or in a couple of months or in a couple of years. And definitely it's going to reduce the emissions, but then whether you compare it with electric vehicles or maybe batteries, there will be segments wherein there will be utilization. Now, if you say you will completely remove that, but then for certain processes, definitely we also require carbon molecule, some of the processes. Then therein maybe we may move on to certain fuel which has a lower carbon content. But abrupt transition, it's not going to happen. Definitely, with the use of hydrogen in different sectors, you may see a change in terms of the emissions. And at present, the bottleneck is the cost, because any industry cannot completely adopt a new fuel until and unless there is some convincing demand or some convincing supply. And at the same time, how the economics work, that decides onto its utilization in an industry. So we cannot accept that this will be a quick makeover to a completely new fuel. It will take time, as has been in the past as well, whenever any fuel transition has happened. So I welcome Professor Sandeep Kumar. He is also here, and you have gone through his lectures as well.
Hi, good evening, everyone. I'm really sorry I got stuck so a bit late. So I think we can take some questions.
So there is one question. Is separating hydrogen from seawater feasible or possible in practical terms?
So seawater, water is actually water in the sense the other contaminants which come, that is the challenge. So it is splitting is water splitting only into hydrogen and oxygen. But when it comes to fuel cell or when it comes to electrolysis, then the problem is that you want pure water, because the other contaminants may cause certain issues. So herein, if you talk about seawater, then there are chlorine content that causes the issues. So there people are trying, and that could be because we know that it requires substantial amount of water as well. And there are certain countries which are water deficit, and there are certain places, regions, wherein scarcity of water will become a problem if we completely move on to electrolysis for hydrogen production. So seawater electrolysis is much being researched, and a lot of prototypes we can see in future which will demonstrate seawater electrolysis.
So another question is there any industrial production of hydrogen from heavy hydrocarbons?
Yes, definitely. As we have discussed, that heavy residual oils, refineries, they want, because refinery will not waste any of even the bottom of the barrel fuel. So anything which could be a value add product from that could be a positive for a refinery. And that, like, so refineries, we know that they have a performance index, and if how nicely, efficiently we process all the products so as to get the maximum energy output, energy value products from it, that defines the efficiency and other of the processes. So there are processes we have also discussed in detail, the heavy residual partial oxidation of heavy residual oils. So it is definitely being used in refineries to upgrade the fuel. Anything else?
So, actually for the heavy oil thing, both the things pathways are being followed. One is to get the hydrogen out of it, so similar to the reforming process. And another thing is the hydrogen is used to upgrade it to lower hydrocarbon chains, or what we call the fracking and cracking. So that is also being employed. So ultimately, it is seen that as the world demand for some portion or the output of the sort of petroleum product has diminished, say example naphtha or furnace oil or LDO, then they have sort of switched their process or modified their process to create value addition out of it, or the product which are in demand. So one is the hydrogen, another is a liquid fuel. So they sometimes they add hydrogen, get the petrol diesel sort of a product, and sometimes they get hydrogen out of it through reforming process, where hydrogen is again used in variety of purposes.
Please keep posting questions, your doubts in the chat box.
There is one more question. So is pink hydrogen sustainable in the long term? Nuclear based hydrogen.
So actually that is a bit tricky. Sustainable, when we say, then the source of electricity itself is questionable, whether nuclear technology or the nuclear process is sustainable or not. The sustainable has a different definition or a meaning for different countries. Say, for example, if it is US or Canada or Australia who have the nuclear fuel with them, it's very much sustainable because it's an energy security for them. But when we look into India, which has faced a lot of sanction in the past 6 decades, we have for long period, we have not got the nuclear fuel for running our plant itself. Then definitely it will be very, very risky affair to invest in nuclear power plant to get electricity, to get hydrogen. So that is definitely one of the major challenge. Another sort of a thing is like environmental aspect of the nuclear process and the nuclear technology. Uh, Whenever you have studied about the nuclear technology or nuclear process, one of the thing is never discussed is what happens to the nuclear waste and who pays for managing that nuclear waste. Ultimately, it comes to the government or the taxpayer, basically. So even if a private parties are involved in installation, managing the plant and all, the waste disposal comes to the job of the government, primarily because of the safety concern, but ultimately the money goes into that. That is not accounted in the cost of generation of the electricity. So in general, if I say nuclear power plant coupled with electricity based hydrogen production is definitely very costly, not cost effective. But there is another pathway which has people have been talking about is because uh, high temperature electrolysis reduces the electricity consumption. So the nuclear power plant will supply electricity as well as the high temperature steam or high temperature water so that the electricity consumption will be low. And because your electricity production itself uh, sort of loses around 2/3 of the energy because it is running on the thermodynamic cycle. So electricity production itself will have a loss of 2/3 of the energy. So rather than that, whatever the hot water is there, you directly electrolyze that. And there you can save significantly on the electricity cost. So those things are being looked into, but a lot of things are still in, I would say, analysis, not even the pilot scale or lab studies or something, still in the study and analysis part. But cost effectiveness and energy security and sustainability for different countries, it will definitely play a role in it.
There's a question by Yashwant Reddy. What are the major challenges of green hydrogen production?
So if you biomass, maybe you can talk about, and electrolysis I will talk about. So the major challenges, if you see when it comes to the user, is that the cost of hydrogen, which we are getting at, which green hydrogen, that is as compared to your blue hydrogen or your gray hydrogen, it is higher. So that cost, at the same time, the cost is higher because our electrolyzer manufacturing, that is a challenge in the sense that at present we do not have much of manufacturing capacity here, and the cost of electrolyzers is high. So the capex is higher. That's so the economics at present is not very favorable in the sense of green hydrogen. That how we will see how that plays at that how that rolls in near future. The other option of green hydrogen, because we have a definition from our government of 2 kg CO2 per kg of hydrogen. So that can also be met using the biomass based hydrogen production. Maybe you can tell about.
So when it comes to the biomass based hydrogen, so one of the major challenge is the availability and the supply chain of biomass waste itself. Because when we look into the heating application or any other application where biomass as a fuel is used, it has sort of a discrete usage. Like industry will use it for 8 hours a day. Houses will use it for 2 or 3 hours a day in a for cooking application and all. So that sort of a thing is quite okay. But if you are looking into hydrogen production, which will be economical, will have to be at the scales. So if it is at scales, then the requirement of biomass for 24/7 of operation and that to tons of biomass requirement on a day, it makes it quite challenging to secure the biomass on a continuous basis. So just to give you one recent example which happened when the biomass procurement created another issue in the society is in the Haryana, the recently some oil company, I think it was IOCL or BPCL, they have invested in the bio CBG plant or the biomethanation plant which was converted back to the natural gas. And compressed natural gas or some compressed biogas was marketed in the open market as a replacement for CNG. It is quite I would say, a good profitable business venture, but it has to be a big plant. So it has to be designed for managing or converting tons of the residual or the agro residue, paddy or the wheat straw. So when it has to operate for whole year 24/7, then you require hundreds of tons of that material to store once the wheat paddy cultivation is gone. So they actually was designed for paddy straw, but they found it economically viable only if they procure wheat straw also from the market. But wheat straw is actually a good fodder for the cattle. Paddy straw is not. So paddy straw burning issue in the Haryana and Punjab is primarily because it is not a good fodder. So nobody wants to invest the money in cutting it and you storing it. So they just burn it in the field. But paddy straw, nobody, means wheat straw, nobody burns in the field. But as soon as bio-CPG plant was full and finally running, in the wheat cultivation or harvesting season, they started procuring wheat straw in bulk in hundreds of tons. And that actually short the cost of wheat straw, which was earlier 5 rupees, 6 rupees in market, which was primarily being sold to the farmers who are having cattle and all. It shot to more than 20 rupees a kg. So for bio-CPG plant, even 20 rupees was cheaper compared to storing the paddy straw for whole year. But for the farmers, it was a costly affair and it affected the cost of production of milk also. So it is a lot of challenges when it comes to the biomass procurement. We have trillions of tons of biomass waste available every year in India, but that is scattered in thousands of squares of kilometers. So that is major challenge. You have to get it from far away places. That increases the cost, the storage, transportation, harvesting. So that is the biggest challenge. To crack that supply chain challenge is the major challenge compared to the technology for converting biomass to hydrogen. So that is my opinions.
There is another question by Dr. Sachin Kamble. So, sir, can exhaust engine oils, which are used in engines, be a source for hydrogen production?
Uh, Means engine exhaust heat.
Oils.
Engine oils as a source for, yeah, so actually, technically speaking, yes, it has carbon and it has hydrogen. So it can go through reforming, but also it has a lot of impurities. So lubricant or the engine oil is having a lot of impurities and its structure has deformed a lot. That's why you are discarding it. So throughout its period of use of like months altogether or thousands of kilometers of run, it actually degrades a lot. Though I would definitely, if I believe that if you are in some research lab or some education institute, you should definitely try it. The reforming of engine oil or waste lubricant, take it from any garage. But only thing is, again, it is one of the thing which is being produced decentralized. Means you will find few liters of waste engine oil being collected in every garage, and then we have lakhs of garages across India. So if somebody have to put up a big plant or a profitable plant, it has to be big. Then it has to create a mechanism to collect all the waste engine oil from across the sort of a city or maybe across the whole couple of districts also, then only it will be profitable. So that is again a major challenge. The same thing we have seen the challenge when it is waste cooking oil, waste biodiesel. So biodiesel has a market. Biodiesel is a good fuel for engines. But again, the waste oil, which hotels are ready to give off free of cost, still just the collection cost itself is so high that biodiesel doesn't compete with the normal petroleum diesel. So these are some of the challenges, and ultimately technology doesn't remain the challenging part, but the economics of scale and its availability.
There is a question by Shreya Bhattacharya. How much do you recommend learning console multiphysics to simulate practical fuel cell and electrolyzer setups, especially with respect to industrial research opportunities?
There are many tools. Actually, it's not particularly about console. Definitely, learning any tool is helpful. So it is not the only tool which can be used, but there are multiple tools which can be used and integrated also for simulating the integrated system.
And also just to add to it that the there is a lot of research which is going on using the COMSOL as a sort of a tool where people actually first simulate using COMSOL, especially the fuel cell electrolyzer. It gives a very good platform to enhance understanding. So definitely for industry, it's a good thing because it gives you a lot of insights, and when you change the parameters, input parameters and operating parameters, how it behaves, definitely it's a good and industry should sort of adopt it. And I would say that even in IIT Bombay, a lot of people are working on COMSOL on this application of hydrogen, fuel cells, electrolyzer, SOFC. So people are using a lot on this, using this COMSOL.
This is another question where Hemant Solanki. Industry is now also looking for green ammonia plants under renewables. So request faculties for if green ammonia related lectures module can be added to the course in future.
Okay, that's yeah, definitely we would maybe introduce it in next. We'll try to introduce that. It's a very good suggestion. We will try to incorporate. Thank you.
There is one query. So like Vaibhav Sharma is worried about like what type of questions will be asked in exams.
So these will be this will be a computer-based exam, and multiple choice questions will be there.
Yeah, but multiple choice question will be both theoretical, conceptual, numerical. So
Yes.
don't just assume that numericals will not come. So there will be numerical problems also.
There is one question. How can hydrogen embrittlement of metal be prevented while transporting hydrogen?
So there are different ways. So actually, what I presume is you are talking about pipelines. So pipelines, they have to be made up of. Maybe we will discuss more when we will talk about in the upcoming lectures transportation. We will cover that portion as well. Although there are different means of transportation, let me just talk about at present pipelines. So there are different ways to tackle this situation. First and foremost is appropriate selection of material with which the transport system should be made up of, whether it is a canister, whether it is a tank, whether it is a tube trailer, or whether it is a pipeline. So appropriate selection of material which should not interact with hydrogen. Then there are other ways also. There could be a coating. There could be certain inhibitors which can also be added. So surface coating onto the inner side, that is also possible, or certain medium which could be added which reduces the embrittlement. So there are different ways of looking at it, doing that. And in more details, we will see towards the end of this course when you will learn about the hydrogen transportation, and embrittlement also we will discuss when we'll talk about the safety aspects.
There is a question by Soumeng. What will be the best placement for new hydrogen fuel production plant beside Bay of Bengal?
Again, I think it is more of a geopolitical question than technical. See, one of the major answer lies in the economics and the geopolitics. Just for example, right now, whatever the new plant that is coming up, it is near the Mundra port in Gujarat for two reasons. One thing is the plant is supposed to have a big solar plant which will supply the solar-based electricity for the green hydrogen production. And second thing is the ammonia plant which will be commissioned near the port, so that the transportation of ammonia to other sort of a global players and customers, it will be easy. So it is more of a, I would say, a Bay of Bengal, because the port near Calcutta, especially, if you say near the Vishakhapatnam port and also it's a big port which can carry a huge ships and all. But if you look into the near Calcutta, it is not right now suitable for the big ships. So it may not become a profitable business for somebody to invest there. So, but yeah, definitely the place where you have the green electricity availability or possibility nearby, which is again near the coast, wind and solar both can be there, but maybe near the Bay of Bengal, the solar insolation is not that high, but near the Gujarat coast, the solar insolation is also high, wind availability is also high, and the port which can cater to big ships and all is also nearby. So there it makes a lot of opportunity there, but in near future, maybe near Mangalore or Visakhapatnam, some places like that who can handle big ships would be the best place to have a hydrogen ports.
There is a question of what are the challenges while handling hydrogen at room temperature after separation?
So the challenges are more severe actually, as we have discussed in the very first lecture about the properties of hydrogen, so the properties are different. So the challenges remains because of the properties of hydrogen. It has a wide flammability limit or high diffusivity, buoyancy, and all that. But we will discuss in more detail in the safety aspect, how each of these could be positive as well as negative in that sense. And at room temperature, when we talk about, although the challenges compared to the other methods which are used for storage, usually because it is low density fuel, uh, that's why you have to take it to high pressure. So the challenges are more when it is high pressure or at a temperature which is other than the room temperature. So there are issues when it is liquid hydrogen related to the low temperature or even at high temperature or higher pressures. So the challenges are less severe at room temperatures. But whatever are the property related issues, it has a very high flammability range. It has higher energy density. It has very low ignition energy. So all those challenges still remains. But definitely the issues of embrittlement, which are more severe under certain conditions, may be relaxed at room temperature.
So there is a question actually which will be coming in upcoming modules also. Material selection related lectures for different types of hydrogen units.
Okay, so every part of it, we will be talking about what are the materials which have been, what are the issues, what are the then possible materials which could better suit for a particular part of the value chain, whether it is storage, whether it is transportation. So this will be covered in more details because the requirements may be different at each and every part of it. So accordingly, this will come up. You will have to wait for those lectures.
There is a question by Swami. In near future, how can we communicate with you?
So our email IDs are there. You can write to us and we will reply. Other than that, if it is related to the course, definitely discussion forum you can post. We will have more live sessions. You can post your doubts. And if it is something research related, then you can write to us. You can mail us. Our email IDs are there.
There is a question by Suresh Kumar. Ma'am, please describe about blending hydrogen with other fuels like natural gas, etc. Is it still an R&D or operational phase?
So, what blending hydrogen with other fuels like natural?
Natural.
Yeah, so actually it is, means I would say it is in R&D with sort of a pilot scale study, or when it is pilot scale study, it is actually in operation. So there are two parts where blending is being done is with the CNG or the natural gas for vehicular use. So there the tanks which are designed for storing CNG, they have been found that with 10 to 20%. It is okay to blend. So with 10%, many places it has already started, especially within the use of the premises of the oil and gas companies who are testing it. So still it is not in the open market, but within the premises where they have their HCNG pumping station, and then they are studying their overall degradation pattern or any challenges that comes starting from the pumping station, material, electronics, and other parts, and as well as the tanks. As far as engine and tanks are concerned, the global sort of studies has confirmed that it is fine. It is not much of an issue. Another application has already been started in Indore is 5% hydrogen blend in PNG, which is the piped natural gas. So it's for cooking application. So for cooking application also 5% is blended. Again, higher fraction are okay. They have been found no issues, especially in the burners or this thing, flammability issues or safety issues. But only thing is the issue is with the pipelines. So whether the pipelines which are used in India, especially for the PNG, it is mostly this uh, uh, underground pipelines are mostly this, I think some fabric, I forgot the actual material. And then when it comes to the houses, the PNG pipelines are copper pipes. So what will be the impact on the copper pipes when we have hydrogen in it? That is to be studied. So, but in Indore, it is already in the pilot stage. In some part of the city, they are already getting 5% blend in the PNG.
HCNG, IOCL tested and they had several buses running on certain routes.
Certain routes, yeah.
I think a couple of lakh kilometers they have tested blending.
Blending.
And they also had that HCNG filling pump, Faridabad.
The IOCL R&D funding of that.
Yeah, please keep posting your doubts under the chat box. If we have any other question, we can take that up.
So there is one question by Dharmaraj, how to prepare for MCQ question. So I would say you can contact Khurmian Gupta. I hope you know him. So Khurmian Gupta, he will make a book and a lot of MCQ. So just jokes apart, I think once you go through the lectures and all, once you understand the concept, attend the tutorial sessions and all, you will have sufficient knowledge that you don't have to have a sort of a guidebook or any book to practice it. So just the understanding of the subject and overall concepts and all should be good enough. So don't worry about that.
Maybe I would share that because some of the queries were related to the slides and transcripts. So this you will get soon. You will have a book on this topic with this particular material. So maybe you can expect by September, October that book. So then you will have a reference book for this course as well.
So there is a question, ma'am, in an upcoming lecture or live sessions, can we cover major challenges in current commercial hydrogen plants?
Okay. Commercial hydrogen plants.
So actually, commercial hydrogen plants right now are mostly natural gas.
These have been running for several decades, right?
So right now, I would say that most of the commercial plants which are generating hydrogen are either coal gasification based or the natural gas based. Only fraction of that is having from the electrolyzer and all, but they are more decentralized, not the big. So you will never see any sort of a big fertilizer company or any refinery to have a sort of a electrolysis based plant. And those electrolysis plant which have been there, like you can say still the nuclear submarines or those still uses the electrolyzer, but they are still very niche application and they also have been running for many decades. So all the technical challenges have been already overcome for them because they are running, and now the new plants which are coming up are still pilot demonstration scale or medium scale plants, and we have to wait to see the actual challenges that will come out of that.
So the units like in refineries or fertilizer industries, they have been using for several decades and the technology is well proven. So there are as such not because it has over a period of time, the efficiencies have improved, those challenges have been overcome. So whatever are the commercial ones, they are the mature ones, but the newer prototypes and others we will see in future. And then accordingly, we will from time to time, we will try to modify the slides, the content as well.
So there is a question by Shaya Bhattacharjee. PEM cells have the biggest bottleneck in terms of cost of palladium and iridium electrocatalysts. I heard that IIT Bombay green hydrogen cream used ferromagnetic materials like cobalt. Can you kindly explain?
Cobalt, PEM, actually for PEM, the best catalyst is platinum still. There are both the major challenges when it comes to PEM. It is the membrane because there is a monopoly of a particular company. That is a challenge, the cost, and the catalyst, platinum or your electrocatalyst, palladium, iridium. Now, it is very difficult to substitute and get the similar performance. Although there is a lot of research being done, people are trying, but this is, I think this is cobalt based. It has not reached to the performance that
Still, I think all these things are still in R&D
R&D phase.
phase.
Yeah. And if you want more details, we can connect you to the faculty who is working on it. You can write separately to us. You can email us and we will connect you to the faculty who is working in this area.
Another question is, what is the agenda of India on hydrogen production by electrolysis?
So it is 5 million metric tons per annum. That is the agenda by 2030. And there are several plans. There are different policies, even state policies are in place. And there are, as I mentioned, there are incentives also for production as well as electrolyzer manufacturing. And there are different technologies also being tested. Like even there are technologies wherein there are hubs and valleys which are coming up, which will look into different ways of comparing even one technology as against the another one. So a lot of work we are expecting in the field of hydrogen. Lot of policy support we could see, and adoption also we could see, but that may take some time. So on the agenda, it is high. In terms of lot of support we are getting from government. There are stakeholders which are also interested and keen on it. Now, how the economics will, herein the economics is going to play a key role. And then with the economies of scale, how the cost will come down, what will be the learning, whether how the enhancement in terms of efficiencies of the processes could be taken care of, all that will define. But definitely it is getting a lot of support.
So there is a question, is gray hydrogen essential for completing the bridge between the fossil and the future renewable sources?
So actually, I would say, means like it is definitely during the transition phase. Say, for example, if everyone is targeting for about the renewable green hydrogen, then if we are targeting hydro, means like solar or wind, then definitely solar and wind will not be able to give us 24/7 continuous supply. Then we have to either rely on the battery storage for the nighttime usage or the coal or the fossil fuel based nighttime production. So still in India, our 67% of energy mix or electricity is coming from the coal. So rather than waiting for the time when solar plus battery will become viable, and then that will give us a sort of a completely green hydrogen, we should actually transition towards that. Okay, let the at least 30% of the electricity in the daytime coming from solar or plus wind, and then the rest of the period let it come from the coal to give us the hydrogen production running 24/7, because that transition period is very much critical for industry to mitigate the challenges they find when they run a big plants. So otherwise, if we just wait for something which will be completely green in operation, we may end up sort of losing the race itself. So because the plants, we have to go for a mega plant, challenges will be there, then we have to rectify those challenges. By the time we are hopeful that within 20, 30 years or so, our electricity mix in the country itself will be, a lot of renewables will be there.
The question, how to overcome the electrolyzer leaks and what are the most suitable gaskets for that?
Leaks, I think you're talking about maybe crossovers. So with PEM, so if it is crossover you're asking about, then definitely it is dependent on the diaphragm or the separator. And PEM has an advantage because of the use of a membrane, and it is a MEA, which is a very compact one. So the crossover is minimized. So it differs from one technology to another. If it is a porous separator diaphragm, then it is possible that with the higher pressures or higher current density, there would be more of crossovers. But that is better in case of the challenge is better taken care of in the PEM electrolyzer because of the compact MEA, which can give you separate pressures. So we have two separate compartments, wherein one side could be at a higher pressure and another side could be at a lower pressure, and that flexibility is seen, so less of such crossover is there.
There is a question by Swapnil Deshmukh. There are still few pilot ideas for trains to run with hydrogen. Whether in India also similar pilot experiments are being conducted.
Yes.
Yeah, so right now in Germany, it's already running. So it has already, I think, significant kilometers it has showcased that it is feasible. Similar thing is being tried in India also. It has been already announced by the government that there will be a sort of a pilot study of hydrogen running train in India. Maybe we'll have to wait. Could be 1 year or 2 years. We'll see.
Sonepad in the route that is funny.
Plastic
Waste is everywhere. Can plastic be used to make hydrogen?
Yes, so plastic can be used to make hydrogen. It has two paths. So one, I think the biomass gasification route that you have studied in the lecture. So that is one of the paths where we are also doing the plastic biomass co-gasification, where up to 25% plastic is being used with biomass, and plastic has almost like 15% hydrogen by weight, whereas biomass has around 5 to 7. So when we blend plastic with biomass for gasification, we get actually more hydrogen. So that is one pathway. Other pathway is through the plastic pyrolysis coupled with the reforming activities. So generally plastics except PVC, which has chlorine, which is difficult to tackle, but rest all plastics can be converted to liquid pyro oil, which is through pyrolysis process. There we get the smaller chain hydrocarbon, and that is then fed to the reformer, and reformer then converts it back to the sort of hydrogen. So in the biomass gasification chapter lecture, you would have heard about the biomass pyrolysis for hydrogen production. The same replace biomass with the plastic, that also works well.
So there's a question by Heman. After completion of this course, can you please share path forward that is specific further courses in India which can be attended as industry professionals to develop ourselves in renewables?
Maybe we can talk about IIT Bombay. We offer different, if it is renewables, we offer different courses. This is through our education outreach. And you can visit our websites and then you can see these are being offered by different faculty. We also offer, but then these are catered for particular industrial needs. So I used to conduct these courses for like different PSUs. And these courses are very rigorous in the sense 4 to 5 days and then at least like 24 hours. These courses are meant for. So such courses are run by different faculty also. It's not only hydrogen, but other renewables also such courses are. Please visit our education outreach website. And if required, can also be designed as per the industry requirement, these courses. And you have to approach our individual faculty or to the Dean Education Outreach, and we can tailor-made those courses as per the requirement of industry.
Can we make hydrogen from water, steam, electrolysis?
Yes, I think that has already have come in that this is SOECs, solid oxide electrolysis, wherein so it is a certain amount of energy which goes into electrolysis process. We already have discussed about the delta G values, and also seen that if you give certain amount of energy as thermal energy input, then the electrical energy input requirement reduces. And that is how it takes place in case of SOEC, which is a high temperature electrolysis, wherein you can use any of the waste heat to make it into steam and then undergoes the electrolysis process. So already definitely it is there. SOEC is the process note for steam electrolysis.
What is the major challenge in alkaline electrolyzer and alkaline electrolysis? How to overcome the leaks because it decreases the efficiency?
So alkaline electrolysis, alkaline electrolysis, there are challenges. I think we have also discussed in the course as well. Challenges in the sense that you are using KOH as electrolyte. So your OH minus ion is moving. So that is the migrating ion. Because of the inertia, it is bigger than H plus ion. So there is certain inertia which, so the adaptation with any change in the load, any change in the current, that is not as quick. So when it has to be integrated with renewables, so in that case, and its counterpart fuel cell also faces the same issues. Although it is the most mature technology, most economically feasible technology compared to the PEM, but it has its own disadvantages. You cannot go on to very high current densities because you are using a separator, and then the crossover issues will be there. And OH minus ion being bigger than the H plus, so it has certain limitations into the transport of the ion as well. So alkaline water electrolysis, definitely it has certain disadvantages, but still it is the most mature technology, and we have very larger size systems which are based on the alkaline electrolysis. Now the issue of leakage crossover, that is, you cannot operate at high pressures and high current densities because it is the construction or the electrolyzer itself that you are using a cost-effective separator. If you want to address that, then you have to go to a different technology wherein you can achieve high pressure, high current density, but the cost, if you are changing the separator, then the cost increases.
And just to give you one example, like when the Bhakra Dam was constructed, so actually there was the fertilizer plant near to that was actually getting hydrogen from the electrolyzer, and that was the alkaline electrolyzers and a very high capacity. And it has run for decades before the natural gas become cheaper and abundantly available and the supply chain was resolved. And so it was shifted to the natural gas based. But alkaline electrolyzers are quite a mature technology. We will have to see whether the PEM can overcome the cost barrier and the use of the rare earth metal, then I think it will be adopted.
Question: can we get industrial plant design where to place rulers?
So this industrial plant design is not within the course structure. That may require a different, maybe altogether a different course, and lot of other expertise, because you have to look at many other aspects rather than the technology alone and their integration as well. So that becomes a major challenge. So it is at present not a part of the course.
There's a candidate who said a question like, today I have registered for exam but missed 2 assignments. So shall I re-register for the course? So it is not required. NPTEL considers best of 8 out of 12 assignments for evaluation. So whomsoever he or she is, they can continue. Okay, sir.
Good. Any other question? Any other doubt? Please post on the chat box.
And then I want to set up a primary hydrogen near Bay of Bengal. What should I follow to set up successfully and create employment? I think someone, maybe you can write to us separately. I think this is not something very trivial. On nothing we can give you answer in 2 minutes or 5 minutes, or maybe we don't have that much expertise to give you a confidence in putting our plant with whatever knowledge we have. So, but maybe we will be able to connect you with the right people. So you just write to us. We will guide you further. What would be required qualifications to operate this kind of fuel production?
I don't know what is your background but I think there are multiple things that plays a key role in plant establishing a plant. There is expertise required in terms of sizing. What is the requirement? You have to also map what is the supply and demand, because how you are at what price you are going to. So economics is required, management is required, then technology, understanding the technology definitely is required. How you are going to integrate, how you see the market at that place. So there are multiple things that needs to be considered, and maybe a single person definitely cannot manage. So there is a team which will be required, which could look across all these disciplines and then come up with. And before establishing, a lot of study is required.
And I would say, Somen, that whenever a new means a big project is coming up, and if you follow the news of hydrogen, the key players who are coming for the installation of the hydrogen production unit, all of them are the big companies, L&T, Adani. So they are big companies who are coming up for the set. So you have to create a sort of a brand name or a confidence in the market that somebody will give you money. That is the first thing, especially when the technology is new in the market. So that is something. So you have to create a team which will be good. So we can't say that what all skill set you should have, but rather than it should be the team which should have the right skill set. Maybe we will, I think our email ID is there on the course portal.
We can post it here
Yeah.
also.
Can
Maybe
post.
at the end of it,
At
we
the
will
end of
post
it,
the
we will
email
post our email IDs.
What type of tool is used to design the alkaline electrolyzer in terms of simulation?
You can use COMSOL multiphysics here.
So SPEN.
SPEN.
SPEN means first you can go for COMSOL, and then COMSOL, what are the output comes, you can then import the data into SPEN. So SPEN will give you the flexibility to design the whole system. But that whole system will have a component called individual electrolyzer, so that you can simulate in COMSOL. So combined, you will get a good output.
What will be the next big thing in logistics? Hydrogen-based transportation or EVs? Or some other technology based on feasibility, technology transfer, and adaptability by person?
Yeah, so for this again, no clear answers. Again, it depends on the customer behavior, the market, and right now for the past few years, what we are seeing is the geopolitics. So where all these things will take us. Just to give you a example, CNG. CNG is a cheaper fuel compared to petrol. Petrol or diesel, it's cheaper fuel. We can convert the existing vehicle to it by just putting a lakh rupees or so. Still, government has to push by regulation that all the commercial vehicles have to be CNG. Then only it started, and that started in 98, 99 in Delhi. And now it's 2025. And if you look into the last month data of how much commercial vehicles which were sold were actually CNG fitted vehicle, it is still around 25% only. So though we have pumping stations, we have the mature technology, we have the knowledge in the market, it's like confidence in the market that yes, CNG vehicles runs and it is cheaper, maintenance, service, everything is there. Still after 25 years, we have seen just 25% of the users prefer CNG, though the economics favor. So it's very difficult to say that how the market will play, but in general, for hydrogen and electric vehicle, there is two things. It is difficult for electric vehicle to penetrate the market for long journey vehicles, whether it is trucks or like marine application or marine ships or the aviation sector. Aviation sector and marine sector, they are still looking for liquid fuel, which could be hydrogen derived sort of a liquid carrier fuel like ammonia or carbon based hydrocarbons, which will be derived from CO2 and hydrogen combined. But looking into the long range land vehicles like trucks and all, hydrogen could be one of the solution. So, but for smaller vehicles, there is a sort of a buzz in the market that smaller vehicles will be ruled by the EVs. Like already you will see the three-wheelers are ruled now by EVs. Slowly it will percolate into two-wheeler and four-wheeler market, but long-range vehicles still, I think we will have to see if hydrogen economy or hydrogen supply chain becomes sustainable, then we will see that hydrogen may be there in the long-range vehicles.
Last question, what is the current process for manufacturing hydrogen on an industrial scale and especially hydrogen used in refineries?
Most of the hydrogen currently produced is through steam methane reforming. That is the well-known process. So basically, that is the process. And like as Professor Sandeep has mentioned, coal gasification to some extent, electrolysis very small fraction. I think we will end this session, and I would like to thank all of you who have joined this interactive session. And we look forward again to your doubts in the upcoming live session in the next month. Hope you will have a very good learning experience. You can share your feedback.
How can we change mindset of the customer to move towards renewable sources of fuel like hydrogen, CNG? How can we really penetrate the market segment?
So, what's your name? Ratio.
Ratio.
So, Rishabh, so good thought, but I think this is not a very simple question to answer, and also not a simple task to just have one sort of a methodology and one process to fulfill that. I mean, it's a very cumbersome thing, very complex thing, reading the mind of the customer, how the market behaves, how even a single rupee sometimes matters to a customer, and sometimes even the saving doesn't matter to a customer. So it's very challenging. It's very challenging. It's something like you will pay 100 rupees for the same naan in a good restaurant. But if somebody asks you the same quality, same taste, this thing in a roadside thela or something, then you will not be even willing to pay 25 rupees for that. So it is sometimes how the customer, what customer wants. Do he wants the taste of the food, or do he wants just a restaurant sort of a feeling inside, sitting inside a cozy restaurant or something. So it's very difficult. As I give you the example of CNG. CNG is very good example in terms of energy market in India. It is cheaper, it is available, it is economical. The market challenges, maintenance, repairs, safety, there are no challenges or no issues with respect to that. Still, customer don't show the inclination in adopting it. So it's very difficult to say that how to tackle that, but maybe person from management or humanities will be able to better answer this question rather than we people who are mostly working on the technology side.
Okay, thank you so much.
Yeah.
Thank you so much for joining for this session.
Yeah. Thank you everyone. See chat.
वो इसमें email ID दे दो. email